All right. Hi, welcome to this week's lab activity, which is stoichiometry. For this week's lab activity, I wanted to start out with this short video because there's going to be some math along with today's activity. So your lab kit is going to have a little envelope that looks like this. It says stoichiometry of a precipitation reaction. So you'll need that envelope. It's going to have in there a little bottle of calcium chloride dihydrate. It's also going to have a little bit of sodium carbonate. And we're going to use these compounds as our starting materials for this week's lab activity. So this is the chemical reaction that we'll be using for today's lab. We're going to take a little bit of that sodium carbonate and we're going to react it with calcium chloride dihydrate. Now, it's been a while, but when we were talking about nomenclature, we talked about hydrates, and these are basically compounds that also include a little bit of water inside of them. When you look at a hydrate, the compound, it might still be a powder. Okay, so this is the hydrate. You can't see the water in it. It's not wet, like, it's not a liquid, but there are water crystals, small, so that they're not gooey or anything. They're not wet, but there are water crystals inside of this compound. So that's what we mean by a hydrate, that there's water that is part of the compound. Well, when we react this together, we actually form three products: calcium carbonate, a little bit of sodium chloride, and then the water comes off of here as well. And so our activity today is going to try to maximize the percent yield of this compound. Now, we did not get to percent yield exactly in lecture, so that's kind of why I wanted to go over a sample calculation of how you would calculate percent yield. So that's what I want to do with you right now, is to do a sample calculation. So let's say, for example, you begin today's activity with these amounts. So let's say you start out with 1.5 grams of calcium chloride. Oh, this is dihydrate, by the way. I left out a 2 there. Calcium chloride dihydrate. And you start out with 1.09 grams of sodium carbonate. So just as a little correction here, I should have had a 2 in front of that water. That's how I know it's calcium carbonate dihydrate. Okay, there we go. That's how I know it's calcium carbonate dihydrate. So let's say you start out with these amounts and you conduct today's experiment. Okay, at the end of today's experiment, you produce 1.03. Well, let's say you produce 0.98 grams of calcium carbonate. And the question is, calculate your percent yield. Okay. Calculate your percent yield. So here is going to be your strategy. You're going to have to start with a balanced chemical equation. That's why my 2 over here was so important. I had written the wrong formula, and it's hard to balance an equation when you have incorrect formulas, but my equation is balanced now. For this calculation, I'm going to have to convert grams of calcium chloride dihydrate to moles. And then I'm going to have to do the same for the sodium carbonate. So grams of sodium carbonate, also convert that to moles. Then the next thing I'm going to have to do is I'm going to have to solve, use moles of calcium chloride dihydrate to determine what we call the theoretical moles of calcium carbonate. And then you'll do the same thing with your sodium carbonate. So use moles of sodium carbonate to determine the theoretical moles of calcium carbonate. I'm running out of room here. Okay, so you'll determine the theoretical number of moles produced by each of those. Then the next step, step 5, is you'll choose the smallest mole amount, and that will determine your limiting reagent. And then from there, we can calculate our percent yield. So this is our strategy. I'll go through it with you. Okay, I'll go through it with you based on these initial amounts. So here we go. We begin with these amounts. Now we want to calculate our percent yield. So I'm going to need to know how many moles this represents. So 1.50 grams of calcium chloride dihydrate times the molar mass of calcium chloride dihydrate. So you're going to have the molar mass of calcium, which all by itself, where's my periodic table? Which all by itself is 40, if I'm correct. Yeah, all by itself is 40. You're going to have 35.45 twice, one for each chlorine, and then water by itself is 18 grams, and there's 2 water molecules, so 2 times 18. All of these together are going to equal the molar mass of the compound. So we have 40 plus 35.45 plus 35.45 plus 18 plus 18. I'm going to just round that up to 147 grams per mole. So 1.5 divided by 147. I'm working with a really small number, 0.0034 mole of calcium chloride dihydrate. Do the same thing for my number of grams of sodium carbonate. And so the molar mass of this is going to be 23 twice because there's 2 atoms, 12 for carbon, and then 16 3 times because there are 3 oxygen atoms in the formula. Pushed the wrong number. Here we go. So that's 106 grams and 1 mole of the compound. So 1.09 divided by 106. That is going to be equal to another relatively small amount, about 102 moles of sodium carbonate. So now the next step is, based on these, try and figure out how many moles of calcium chloride I'm going to produce. So I have to look back at my balanced chemical equation. And this is going to be really nice because my coefficient here and my coefficient there is 1. My coefficient here and my coefficient there is 1. So what that means is, if I look at the first step, if I produce 0.0034 moles of calcium chloride, if I start with this many, dihydrate times 1 mole to 1 mole, that means I'm going to produce the same amount of calcium carbonate. So since it's a 1-to-1 mole ratio, however many moles I have here, it's going to be equal to that many moles I have there. So I really don't even have to do any math. That is so nice that whoever designed this lab picked something with the 1-to-1 mole ratio. So I can set up the problem, or I can just say that the number of moles is equal, 0.0102. What both of these represent, this is my theoretical yield of calcium carbonate based on initial amounts of each reactant. And if you remember from lecture, when I look at the 2 amounts, I pick the smaller of the one because the smaller of the one indicates who is my limiting reactant. So if I compare these 2 numbers, the 0.0034 is the smaller theoretical amount. That means that this is my limiting reagent. In other words, when I do this activity, I'm going to run out of calcium chloride before I run out of sodium carbonate. I'm going to have some of this left over, but I'm going to use up all of my calcium chloride dihydrate in this reaction. So looking back at this equation here, this is going to be my limiting reagent. So the most I can produce is this much calcium carbonate. That's the most that I can produce. The last step is, let's say when I'm all done, according to the problem at the end of today's experiment, I produced 98 grams of calcium carbonate. And I want to know, what is my percent yield? Well, according to my problem, I'm going to produce this many moles. This is in grams. This is in moles. Oh, you can't see. Here we go. Now you can see. So here's how much I produced, but this one is my theoretical yield in moles. This right here is my actual yield because it's going to be what I did as part of the lab experiment. In order to calculate my percent yield, these have to be in the same units. So they can both be in moles or they can both be in grams. It doesn't matter. You decide. You can convert this number or you can convert that number before you calculate your percent yield. I'll do it both ways. That way you can see how this works. So here's how we'll calculate our percent yield. It'll be our last step in our strategy. This is step number 5, I think. So calculate percent yield. And your percent yield is going to be equal to your theoretical, your actual divided by your theoretical times 100%. That's how you'll calculate your percent yield. So we already calculated our theoretical yield, and it was this smaller number. So I can convert this number to grams if I want to, because it's going to be based on the grams of calcium carbonate. So calcium carbonate has a molar mass of, this again is 40, 12, and then 16 3 times. I'm writing it out this way to remind you how to calculate molar mass. And there's my calculator. So that is 111 grams per mole. So now I'm going to convert 0.0034 moles of calcium chloride. I'm going to convert it to grams. So 1 mole is equal to 111 grams. So that would be 0.3774 grams of calcium carbonate. Or I can convert 0.98 grams of calcium carbonate to moles. Eight moles. So either way, I have my numbers that I need. So this number right here, that 0.0034, again, that represents, this was my theoretical. So this is my theoretical. This is my actual. And this is my actual. All right. So if I'm going to calculate percent yield, I'm going to do actual over theoretical times 100%. So if I use these values, it would be actual be 0. Oh wait, if I can use I'll use my mole values first because I have both of them. So my theoretical mole value is 0.0034, and I made 0.98 grams. So 0.0088. Hey, I'm going to have over 100%. How is that possible? That's like 250%. What? $250%. Or I can use the gram amount that's going to come out less. I don't think I did that right. Oh, I might have to start my video over. Hold on, let me check. Let me check here, Nayeli. What did I do incorrectly? 0.34. That's my theoretical. Okay, that number's okay. That number's okay. The 2 mole amounts. Oh, I'm okay. I'm okay. All right, I'm okay. Or, here it is in grams, 0.98 grams over 0.3774 grams. It's still going to be over. Yeah. It's still going to be over. And so how can you have something over 100% yield? Means you have an impurity in your end product. Means that there's an impurity in your end product. So likely you have unreacted whatever is your reagent in excess. In this case, our reagent in excess would have been the sodium carbonate. So don't be surprised if for this reaction you end up with more than 100% yield. You won't get 250% yield, but it wouldn't surprise me if you end up with like 98% or 101% or something similar to that. This particular reaction, I'll let you know, is kind of made to give you an incorrectly high percent yield so that you think about why it is that you would have a high percent yield. And most of the time, the reason that you have a high percent yield is because there is extra stuff in your end product that should not be there. And so for today's lab, I don't want you to be intimidated to do it. It's not a difficult lab to do. The math, I promise you, is not that bad. It's just there's a lot of steps in it. So I wanted to make a short video on how to do the math for today's lab, just to kind of demonstrate how it will work. I'm going to turn off my camera or my recording now.